Hello, in this video I'm going to give a little background to J.J. Thomson, the physicist who's probably best known for discovering the electron around the turn of the 20th century. So, about 125 years ago or thereabouts. And that was the first known subatomic particle. So we'll get back to that in a little bit later on. But I mean, that's one hell of a breakthrough. To have found the first, conclusively found the first subatomic particle, the first thing smaller than an atom. Thomson, born in 1856 in Manchester, in England. He was born into a religious family. They were a family of devout Anglicans, so members of the Church of England. And he went to Trinity College, Cambridge, as so many of the big name scientists did back in the day. And he completed a maths degree when he was at Trinity. That's where while he was doing his studies and getting into physics, he met his future wife, Rose Elizabeth Paget, who was also interested in physics. But of course, she wasn't allowed to study it because women weren't allowed to study physics, at least not formally at university back then. So she was interested in it and she was allowed to go along to lectures and such like. But yes, there was a long way to go on the path towards equality back then. But still, they met over their shared love of physics, and they had two children, one of whom, George Paget Thomson, he also won a Nobel Prize. I mean, J.J. Thomson, he won a Nobel Prize in 1906 for his work on the conduction of electricity in gases. And his son, George, also won a Nobel Prize, sort of following in the footsteps of his father, because that work was on the wave properties of the electron. Quite a high achieving family. Now, when Thomson discovered the electron, it was a major breakthrough, but it's not that nobody was thinking that there were subatomic particles. I think there was an element of surprise that it was a particle that was so small, based on findings, in chemistry and such like. There were a lot of people thinking that the basic unit of an atom was going to be something proton sized. I mean, that was the main distinguishing feature in the weights of different chemical elements. But Thomson, he was doing studies of cathode rays. So cathode rays are, or now we know that they're electrons emitted from the negative terminal of a voltage supply. So he was setting this up, and he knew these particles were being emitted from the cathode, and he was studying how they would behave. So how far would they travel in air? How much heat would they generate if they were fired at a metal, say? What temperature change would happen to that target metal? How much would they be deflected if they were fired through a magnetic field? So he was looking at all of those different things. I mean, looking at the magnetic field, this is essentially starting mass spectrometry, really. But you're looking at everything that's going on there, and it's telling you about the energy. It's telling you about the mass. It's telling you about the charge. All of these things, how much something is being deflected in this magnetic field. That's telling us about the mass and the charge. The heat generated on impact, that's telling us about energy. You've got all of this stuff. If you piece all of this together, which is what Thomson did, he then found that this particle, these cathode rays, were made up of subatomic particles that were much smaller than the proton. And that was, that was one of the things that was quite surprising about it all. Alongside all of his scientific work, actually his experimental work and his discoveries, he was also a teacher at university, and 7 of his students went on to win Nobel Prizes, which is almost unparalleled. I think there is some other, I can't remember off the top of my head now, there is another Nobel Prize winning scientist who's got this great big glut of students who won Nobel Prizes as well, but I can't remember who it is. But Thomson, 7 students, including Rutherford, and Lawrence Bragg, who's you might have heard of, physicist. He was associated with X-ray diffraction and sorting all of that out. So yeah, he was really at the heart of things, Thomson. He was a real groundbreaker in every sense, both in terms of his discoveries and his teaching. And his ashes are in Westminster Abbey, near to Newton and Rutherford, who was one of his students. So yeah, remarkable chap. And yeah, I mean, he's never going to be forgotten for that discovery of the electron. But he was also he came up with his then first model of what an atom was going to be like, that sort of plum pudding model where everything, the electrons were stuck into the nucleus in the same way as the protons in this sort of lump, which of course has then shown not to be true. I mean, well, Rutherford in his experiments, when he then saw that the nucleus was very small and these electrons were outside of the nucleus because the nucleus had to be strongly positively charged. So it's not that Thomson had the answer to absolutely everything, but he was right at the forefront of all of this discovery when looking at subatomic particles.